This is the required practical for GCSE, looking at calculating the specific heat capacity of a metal block. The specific heat capacity, by definition, being the amount of energy you require to raise a unit mass, in this case a kilogram, of a metal by 1 degree C, or 1 Kelvin. They're the same. So you have various things that have to go into that formula. Delta E equals mc delta theta. So the amount of energy going in needs to be calculated. I don't have a joule meter, you possibly do. If you've got a joule meter, it will just measure it for you. But I'm going to have to go with using the formula P equals IV. So I need to know my I, the current flow, which I have on this ammeter going into my heater, and I need to use V. Now you might use a voltmeter, in which case it must go parallel and plug straight in across the immersion heater. I don't need to do that because my power pack is reasonably accurate. I get a voltage reading on it. I've currently got it set down low because it's plugged in, but I'm not doing the experiment yet. You may need to weigh the mass of your block. If you want to do that, then a balance will do it for you. I don't need to. I know that my blocks are exactly 1 kilogram. I've measured them before. They're all a kilogram. I've got 3 different ones I can check. This is aluminium, 2 holes in the top, 1 for the immersion heater, 1 for the thermometer. This one is iron, steel, same again. It looks smaller, but it's more dense. It is a kilogram. And this one is brass, which is an alloy. You can get other ones. You can get copper ones, nice pinky colour. But we use those 3. I'm going to put my immersion heater in there, and I have a thermometer and place it in there. Going back to the formula, you need to know the amount of energy going in. Well, P equals IV. P equals I times V. You also know that P equals energy over time. Power is energy over time, so energy is power times time. So I need to know how long I do my experiment for, which is why I have my stopwatch ready, and I can do that. I need to convert it to seconds. That gives you an overall formula, if you want to use it, of energy equals I times V times T. Multiply the 3 together, it will tell the total amount of joules that goes into this. Now you're always going to lose some energy. I'll go over at the end of this all about the exam questions you might get, and one of those is why you always get the wrong answer and the energy loss. So we'll try and minimise that by insulating that against the desk, and I can also put this insulation around the block to try and minimise that. You might want to put one on the top. That will give us the better result we can get. The formula has in it a delta theta at the end. Delta, the triangle, means change of. Theta we use for temperature. So change of temperature, I need to know the starting temperature of my experiment. So I read that off here, and I've got in this classroom exactly 20 degrees. I'm then going to start my experiment. So I start that while I turn my voltage up. These are actually, that we have, are 12 volts. So I'm going to run that at 12 volts, as best I can get it, 11.85. Write the voltage down, write down the current flow. I've got 3.63 amps. As this heats up, it might change. These values might change, especially the ammeter reading. So I would take readings for volts and amps every minute that I run my experiment for. Then I can take an average of those, or I can check whether they changed just initially for the first minute and then they were the same. But it's worth doing that because you'll get more accurate results. How long you do this experiment for will depend on your equipment, on your potential difference, and how good your immersion heaters are, as are only about 12-15 watts, so you don't get an awful lot of heating from them. Check the temperature, and I would recommend doing this for a period of time that gives you a noticeable change of, let's say, 10 to 20 degrees. Don't let it get too hot. If it gets too hot, you're going to be shedding heat thermally to the room, and that's going to mess your results up. So probably I would give it from 20 to 35 degrees. See how long that takes to go. Very important now, when you come to the end of your experiment, you're going to turn off your power, you're going to stop your time, but do not take the temperature yet. Invariably, this will carry on heating up because it's going to take time for the thermal energy to dissipate through the block, through conduction, and hence you'll find that you might get a couple of extra degrees going up on here over time. So monitor that, and you take the highest temperature it gets up to after it's been turned off. But the time you take is the time when you turned it off. I'll go through the maths in a minute. I've got a PowerPoint ready, I'll put some slides up and we'll pick through that, and I'm also going to go over the kinds of questions you might get in the exam, especially the 6-point markers and how you're going to get all of those marks. So next, let's have a look at some questions you might get in an exam, particularly the more difficult 4 to 6 marks on how you would describe performing this experiment. While we're looking at that, if you wanted to have a look at my website, there's a donate button there, and I also run free online live tutorials as well as online teaching and one-to-one tuition. So the 6-mark questions that come up on the exams, you have to think about and plan setting out these different parts of the question. Don't just list your apparatus. Make sure you list the apparatus and you say specifically what you are measuring, the units you are measuring it in. If you're going to change something in your experiment, so you might be taking a variety of readings, changing your independent variable, give the range of that you're going to give. Think about any control variables that you've got. You might need to keep certain things the same to make it fair. You might need to keep it insulated, make sure the insulation is the same thickness every time. And lastly, at the end of your answer, if there's any formulas you need to do, any calculations you need to do, any graphs that you would have to draw, state what those graphs would be and state what you would put on the axes. Here is a stock example answer that I might give to the simple question of how you'd find the specific heat capacity of a block of iron. Note each of those bullet points I've gone down. Weighed it, what I've weighed it with, temperatures, what I've measured, how I've connected it. You have to make an assumption that you don't need to draw a diagram for this, but that just saying series and parallel will be sufficient. And finally, I've gone through the formulas. You tell the marker that you understand what you're doing, and at the very end, possibly as a separate answer to a separate question, you've got the systematic error and uncertainty that always comes up in this experiment. Insulation helps, but it never gets rid of it completely. Well, thank you. Good luck in your exams. Check out my other videos on my site and please visit my website.